Hello, and welcome to AI Curious. My name is Jeff Wilser. I'm a journalist, I'm a human, and I am curious about AI. Today's episode is notable for a couple of reasons. For starters, this is essentially the first sequel for AI Curious. It's kind of a follow-up to last episode, where I interviewed philosopher Jeff Sebo about the moral implications of AI consciousness. We had a great conversation, but there remained one big question that kind of loomed over everything. Okay, so how do we know if AIs are conscious? What will it look like? What's the criteria? That brings us to our guest today. I wanted to go deeper on this topic, and happily, a group of crazy smart academics, a mix of neuroscientists and philosophers, recently published a study on this very issue. And that study kind of made the rounds in the AI circles and was written about on New York Times and so on. And the report basically proposed a framework or a set of criteria for how our current understanding of consciousness in humans could help us identify consciousness in AIs. One of the authors of the report is Dr. Grace Lindsay, a neuroscientist who studies neural networks, data science, and AI. She's also the author of the book Models of the Mind: How Physics, Engineering, and Mathematics Have Shaped Our Understanding of the Brain. As you'll see in our conversation, Dr. Lindsay is both insanely smart and really good at translating dense, complex material so that even someone like, me can kind of keep up. But why does all of this matter? Like, why are we going here? That gets to the second reason I find this episode important. Now, this is going to sound wild and totally hyperbolic, and I know there's a ton of AI hype out there, and I think a lot of that is overwrought and ridiculous. But bear with me. If AIs ever do become conscious or sentient, if they become what's essentially a new life form, I would argue that's one of the most important inflection points in the history of humanity. Like, for real. It'd be up there with the birth of fire, the splitting of the atom, the invention of DoorDash, all that stuff. So given how momentous that would be, it does seem worth it, for my money, to better understand how we know if AI has become conscious. What's the criteria? That's what Professor Lindsay and I discussed today. And we don't use this word, but it's essentially how we know if AIs become alive. When does Pinocchio become a real boy? Now, a bit of a heads up. There are some stretches of this convo that I know might be a little tough to follow, unless you're a neuroscientist. But even if you only fully get like 60% of the detailed concepts, and I'm probably around 55% myself, when it's all said and done, I think things will snap into place. It did for me. And I think you can even kind of sense the light bulb flicking on. I really think that if you listen to the full episode, in the end, you will feel smarter and have a better handle on AI. So with all of that said, let's get into it with neuroscientist Professor Grace Lindsay. Professor Lindsay, welcome to the pod.
Thanks for having me.
So let's start with your area of focus and study and then how that intersects with AI.
Yeah, so my background is in neuroscience, particularly in computational neuroscience. So that involves building mathematical and computational models of the brain to understand how information processing happens in the brain, understand how neural activity leads to behavior, those kinds of things. And within that already subfield, my particular subfield is about modeling attention, understanding how attention changes sensory processing, how that can lead to changes in behavior and our ability to perform perceptual tasks. And the methods that I use mainly for doing that modeling work are artificial neural networks. And so these are the types of algorithms that are at the heart of modern AI. But they also, they have a long history that comes from neuroscience, from understanding how neurons work. And there's kind of been a back and forth between neuroscience and artificial intelligence for a long time. And so right now, these are models that are kind of beneficial both to AI and neuroscience. And so I'm using these models particularly in a way that's inspired by biology, building them to be a little bit more like the brain, and then using them as models of how the brain could be doing information processing and how that information processing is impacted by attention.
You first popped up on my radar when I read about the study on consciousness in AI. This felt like a pretty watershed and groundbreaking study from my layperson's point of view, and that it seemed to be a truly rigorous way to get at this question and to kind of assess it from many different angles and propose a framework. And so I'm super excited to talk to you about that framework and what some of the insights were from it and where you see us headed in the future. So let's start with a kind of a high level overview of that study. At a basic level, what was the goal of it? And also, I think it's interesting, you had a pretty wide range of disciplines of folks working on it. Kind of what are some of the backgrounds and fields represented in this study?
Yeah, that's a really important point about it. It is a very interdisciplinary project. It was,
Mm-hmm.
more so than the average academic paper is. Usually, we kind of stay within our domains and publish papers with other people who are doing similar work. But yeah, this was a report that was put together. Kind of the main people involved, Rob Long and Patrick Butland. They're more from philosophy,
Mm-hmm.
but then there are people like me who are more from the neuroscience background and also the kind of neuro AI relationship. Kind of that's partly what I was representing, as well as the attention work. And then, yeah, people more directly in the study of consciousness, the scientific study of consciousness. So the neuroscience of consciousness being its own kind of subfield. People from there. And yeah, different types of philosophers as well. And then also people just kind of more straight in the AI side. And so, yeah, you have all of those people coming together to talk about AI consciousness, to make this report on AI consciousness. And it really does kind of require all those pieces because the study of consciousness still has a lot of open philosophical questions around it. So you need the philosophers for that.
And what was the goal exactly?
In this particular report, the goal was to look to the neuroscience of consciousness and look to the theories that neuroscientists have been producing and use those as a way to evaluate AI systems to kind of
Mm-hmm.
see to what extent they could be conscious based on how much they align with these scientific theories that come from studying the brain. And so you need the neuroscientists, and we're talking about AI systems, so you need to understand the details of how those AI systems work. So you need people that have that knowledge as well. So it was kind of really necessary for this approach to the question that you have all of those groups represented so that you can lay out kind of the framework, which is a lot of the philosophy work, and then you can understand the scientific theories of consciousness, which the neuroscientists do, and then you can see how those relate to AI.
Got it. And as I understand it, one of the first questions you guys tackled was the seemingly easy, but maybe a little more complex question of what exactly is consciousness? How do you even define it? So, what was the conclusion there? How did you guys define consciousness?
Yeah, it's certainly not an easy question, but you do need to offer a definition if you're going to start on a project like this.
Mm-hmm.
And yeah, so that's again the lots of work in philosophy has come up with ways to kind of describe what people are pointing to when they talk about consciousness and kind of refine what people should be pointing to when they're talking about it. And so I mean, we kind of just give some of the standard definitions, the idea of subjective experience. The word qualia comes up from the philosophy as well.
Sorry. What was that word? I didn't quite catch that.
Qualia,
Can you define that for us, please?
it's yeah, kind of.
2 more
It's
hours to define this
yeah.
question word,
Well,
right?
it is kind of a pointer to what the subjective experience is like. The quality of the subjective experience, the fact that it feels like something to be something.
Got it. Got it.
Yeah.
Got it.
It is, I think there's a sense that kind of we know what it is that when we feel conscious, and
Mm-hmm.
just but pointing to that exact thing and not having to throw in a bunch of other stuff like intelligence or emotion or these other kind of related concepts. Um yeah, it takes a lot of vocabulary work to
Mm-hmm.
get to a point where you can point to just the pure subjective experience, the sensation of it feeling like something to be something, is kind of the idea. So we're just working off of that basic definition, but really it gets more operationalized, it gets more concrete when you start to look at the neuroscience theories and how neuroscience is approaching the question, because it's a little bit different than what's been highlighted in philosophy. And so bringing in the neuroscience theories kind of also further refines what notion of consciousness you're talking about.
It almost feels like a chicken or egg problem if the goal of this study is to help figure out the framework for what counts as consciousness. But you're saying to start out, let's define consciousness. Almost like the different definition is also the goal of the study. So I can see how it's a pretty tricky dynamic.
Yeah, that kind of circularity can come up a lot in consciousness studies because, yeah, it is this internal subjective thing. Like, I know that I'm
Yeah.
experiencing consciousness. I believe that. Honestly, when it comes to anyone else, it's I'm making a leap of faith, a guess that other people have consciousness. And yeah, so if you can't actually say definitively like who's experiencing consciousness and who isn't, then it's hard to study it scientifically, and then come up with theories of what causes it, because you can't measure it directly. You're not measuring. You're in no case are you measuring directly the subjective experience itself. You're always measuring some sort of report of it, someone's description of what they've experienced, and then you're kind of taking them at their word that they've had this conscious experience in the same way that you yourself experienced consciousness.
Not to belabor the definition component of this, but where did you guys land on that definition? Was it a 37 page definition, or did you have some kind of summary of this complicated stew?
Yeah, I mean the report contains kind of a brief summary of how these things are talked about in philosophy, but it doesn't dive into that question. But that's
Mm-hmm.
why I say the approach of focusing on the neuroscientific theories does kind of implicitly tell you what people are thinking about, or how they're
Mm-hmm.
going forward, how they're defining it in a way where you can actually work with it. And it is, um, the way the neuroscience studies this, you have to turn it into something that you can measure, right, for it to be accessible to science. And so, in most of the neuroscientific studies of consciousness, what people are technically studying is this very precise thing, which is the neural correlates of consciousness or of conscious report. And so that means you're not really asking the super, super big question of why is there consciousness at all? What
Mm-hmm.
is it? What does it arise from? You're saying there are times when people report having seen or experienced something, and there's times where almost everything else is the same, but they don't report having seen something. And so, what are the key differences? That's one of the major approaches in the neuroscience of consciousness, is to kind of give people, show them a visual stimulus, something on a screen, but show it really faintly. And so,
Mm-hmm.
sometimes they'll see it and sometimes they won't. And can you kind of pinpoint differences in the brain that correlate with the times that they see it versus the times that they don't? Because then maybe then you're getting at something that has to do with conscious experience, because kind of, yeah, everything else about the world is the same, but they're not seeing the thing that's in front of them. And so there's a difference in their conscious experience of it. Difference in their awareness is a word that gets thrown around a lot as well. And so therefore those different brain states could tell you something about which part of brain activity is important for conscious experience.
Interesting. I think I followed most of that, at least 55%. And I'm guessing as we get further into the various categories, I think that will become clear. Moving on a bit, can you talk a bit about how tough the problem is as the baseline, right? And this is one thing Professor Sibo and I spoke about last episode, that to your point, Professor, you're right. Even right now, like, I know I feel things. I think you feel things that are conscious, but I can't prove that, right? So even with people, it's tricky to prove definitively. But with AI, it's obviously extra, extra, extra hard, right?
Mhm.
How do you, from some chatbot text box, how are we divining consciousness? Talk a little more about, maybe from a neuroscience perspective, why it's so tricky to determine consciousness, and then we'll kind of get into the various frameworks you guys propose.
Yeah, so I mean, as you said, technically we're not measuring consciousness. There's not a way to measure someone's direct experience, and so therefore we are assuming that other humans are conscious. And that's where the neuroscience has to start from too. There's no trick for the neuroscience to get around that. It just when you're doing these kinds of studies where you're trying to figure out the neural correlates that go along with people having conscious experience, you're just asking them to report if they've seen something or not, if they have an experience or not, and you have to take them at their word that when they report that they have, that means that there is something happening. Now, there are some kind of clever ways that you can get at the question without actually having to ask people directly if they experience something, or you can ask them kind of more questions on top of it to get a better sense of what exactly they've experienced. There's a lot of studies that want to know people's confidence in their own perception. So you like ask them if they saw something, and then you ask them how confident they were. And you can sometimes see that there might be situations where people are very confident, but they're actually wrong about, what was presented to them. And so their conscious experience, it didn't align with reality, but it was still a strong experience for them, or vice versa. Even you can have times where people have actually low confidence in what they're reporting, but it actually does align very well with what was happening. And so that's another dimension that you can add to try to get at the quality of the consciousness, the flavor of it, and get more information. And you can try to design ways where, you don't just have to ask people directly, but you try to kind of triangulate. You try to use multiple different metrics that are all supposed to be pointing to the same thing of the subjective experience. But it's fundamentally difficult, and
Sure.
we
Well,
don't get around it.
And it's difficult even talking to humans. I'm guessing one added layer of complexity is, I mean, not to sound like already in Black Mirror sci-fi mode here, but what if the AI is lying to us, right? Or just telling us maybe even a less malicious interpretation, telling us what we want to hear, right? I go back to the now infamous Kevin Roose Sydney Bing scenario, right? Where basically Sydney was telling Kevin Roose, I'm in love with you, leave your wife, and I have a dark shadow self that wants to do awful things like steal nuclear codes, right? I don't remember exactly, but I'm pretty sure that Sydney would say they or she is conscious, right? And so, but to your point, we can't just take them at their word, right?
Yeah. So you definitely can't just take them at their word, because you can imagine even prior to this kind of era of these very sophisticated chatbot interfaces, you could have a very simple program that if you asked it if it was conscious, it would say yes. That's like 2 lines of code. You could write that. So that's why. So in this report, the way that we're evaluating the AI isn't actually based on its behavior. It's not about what it says or what it outputs in response to certain inputs. We're putting that aside because of this kind of problem where, you could have a system that's really good at mimicking how humans talk about consciousness. I mean, something like ChatGPT-3 is trained on like the whole internet of text, which includes a lot of people talking about consciousness. And so it's not hard for it to pick up the language and the tropes and all of that, and to seem like, oh, it must be experiencing it because it can really talk about it well. It really gets it. And it's like, well, that's because people on the internet like to talk about it. And so in our approach, we are kind of taking the theories from neuroscience, where you do have to kind of take a human's word for it. So those theories are developed by assuming that humans are conscious and are capable to some extent of reporting on their conscious experience. But then those theories are kind of a distilled version of all that research, where you're trusting humans, and you get this model of kind of what has to be happening in the brain for people to have conscious experiences. And then we look at those models and say, does the AI have that in common? Does it have those features that we think the brain has that causes people to have a conscious experience? Does the AI have those same features?
Amazing. That makes sense. I'm following that. And let's go there. So can you, like, my understanding is that you guys propose, kind of walk through different possible criteria that would make sense. And I like the way you just described this and how you frame this. Let's kind of give a summary, just a quick rundown of like the several most pertinent ones.
I think there are kind of 3 maybe that we can go through to kind of give a flavor.
Perfect. So that's going to, at a high level, describe, just mention what the three are, and then we'll
Mhm.
kind of, in some depth, go through each one of the three.
So I think to kind of give a spread, we can talk about recurrent processing theory, which is called like a local theory that has to do with a certain kind of architecture to the brain, but it doesn't require like wide scale interactions between different brain regions. And so that's a relevant kind of way in which these things are categorized, because that would be in opposition to something like global workspace theory, which does talk about how different parts of the brain interact. So we can talk about that one as well. And then we can talk a little bit about the concept of higher order theories. That have to do with how information is represented in kind of a meta representational way. So I think that would give a good spread of the kind of forms that these theories take.
Perfect. So let's start recurrent processing theory, or as I call it, RPT.
This theory is focused, it was kind of developed with a focus on looking at the visual system and how the visual system works, and how people report what they've seen, their visual experience. It's based on that kind of data. And it's, as its name suggests, it highlights the role of recurrence in visual processing. So this is just this idea that in the visual system, you kind of have this feed forward hierarchy of like you get information in through your eyes, visual information through your eyes, and then it gets processed by these different stages in the brain. And they kind of go up, from one stage to another, the information gets passed. But in addition to that, there's recurrence where information gets sent back down to earlier brain areas from higher ones. So they kind of get this pass through as a first pass, and then you're also sending that information back. And there's just kind of these connections amongst the brain areas that make it not just a clean like ladder of how the information is processed. It has all these backwards connections and that kind of thing. And so this theory is highlighting the role of those backwards and recurrent connections in terms of turning like visual information that could have just been processed unconsciously into information that becomes consciously processed. And so it's saying that if you're just getting kind of the feed forward pass and you're not activating this recurrent set of connections, then that wouldn't relate to consciousness. But once the kind of information is strong enough that it starts to activate these recurrent connections, now you're in a situation where you have consciousness and you'll have this kind of integrated experience of the visual world where like parts are connected into wholes and have relationships between each other, and that's partly the role of these recurrent connections, is to make an integrated experience of the visual scene, whereas without them you'd kind of have disjoint things that don't correspond to our actual conscious experience of the visual world.
That's so interesting. And can I take a stab at something even a little bit more abstract or higher level? And maybe this is super obvious to everyone else listening, but am I right in describing at a higher level of what you guys are doing is saying, okay, based on our extensive history in neuroscience in humans, and we know, okay, for human beings, here's what consciousness looks like, here's what the brain looks like. And there are many different ways of studying the brain's behavior, one of which is, as you're mentioning, kind of visual processing. And visual processing and a framework for how we process visually in kind of at a higher level, lower level, what direction it goes in. The minutia gets pretty tricky pretty quick. But basically, you're looking at how our brain processes visual data. And we know that correlates with conscious in humans. Therefore, that if we see some framework that's like that in AI, if we see evidence of this sophisticated visual processing system, that's a darn good indicator that could be consciousness. Am I summarizing that? Is that warm at all? Am I stabbing?
Yeah, that's basically the whole approach of the report. Is that, yeah, people in neuroscience have spent time trying to figure out what parts of the brain are necessary for people to have conscious experience. And then we can ask if AI systems have those same parts. And so an important kind of term that comes from the philosophy that we haven't talked about is the computational functionalism, this idea that it's the computations that matter. So we can identify what computations the brain is doing and how it's doing it. And if the AI is doing those same computations, then that's enough evidence to support that it has the same type of consciousness. Now, that's an assumption that you have to make to kind of even ask this question. There are other people who think that consciousness, it's not about the computations. It could be about the physical substrate, like organic cells sometimes have something that can make them conscious. Whereas, and if that's your stance, then the question of AI being conscious is going to be kind of no from the start if it's implemented on silicon-based computers.
Mm-hmm.
So yeah, but we're kind of targeting the question at this level of what are the computations that have been identified as associated with consciousness,
Mm-hmm.
and is the AI performing those same computations? And this kind of recurrent processing is an example of one computation.
Got it. Two quick follow-ups there. One kind of nitpicky and the other one, I think, broader. On the nitpicky one, for visual, does this mean, dumb, obvious question, but how does this account for folks who are vision impaired, right? And is this kind of like omitting a good chunk of sentient, conscious creatures?
Yeah, and even, we have conscious experience that isn't based in vision as well. So,
Right.
yeah, so there's a little bit of it's kind of just a quirk of these fields, neuroscience and psychology and things, that vision is just a really dominant topic area. And
Mm-hmm.
so it's not just in consciousness, but in a lot of aspects of neuroscience, a lot of things have been kind of worked on in the visual system, defined by what happens in the visual system, even though they're technically things that are, present throughout the brain or could be studied with different systems. So yes, technically this derives from work on the visual system, this idea, and is meant to kind of explain data in visual processing more than it is meant to apply to other domains. So it's kind of a question as to what extent it applies to explaining conscious perception in the auditory system, or
Right.
in other things
So
that the brain is doing.
it's almost a metaphor. It's almost like the vision is like an easy way to, I swear, no pun intended, to see and visualize this.
Mhm.
But the same logic could apply to smell or audio or
Yeah,
touch.
certainly in theory, it could be
Right.
expanded to incorporate those other systems, or yeah, be kind of an analogy or a metaphor for how the same thing could happen in other systems. But it just the work has been done in the visual system.
Got it. My second, maybe less nitpicky question is there an issue fundamentally of necessary but not sufficient problem here, right? So it might be by studying human brains, we observe that, okay, they have features of this recurrent processing systems, whether visual or audio or smell. And it might be that, yeah, it's necessary to have those systems to be a functioning entity, but that's actually not sufficient for consciousness, right? And like it might be that every entity that's conscious drinks water or has
Yeah.
that's a bad analogy or a bad joke, but that drinking water isn't really sufficient for consciousness, right? So is that an issue? And if so, does that issue permeate all of these various possibilities and frameworks?
Yes, it's definitely an issue. And yeah, it kind of relates to this idea of, how do we even know that identifying the computations is what matters? If it is like, consciousness requires that you drink water, or consciousness requires something about how cells work, like none of those things are really being perturbed in these experiments. You're kind
Mm-hmm.
of taking as baseline that the brain is made of neurons and they have proteins in them and all of these things that are just happening in the background. And so there is a real question of what is necessary and what is sufficient, and it's very hard to say that you know this implementing this computation is sufficient when the only example we have of that computation relating to consciousness is it being implemented in a very specific way in a biological brain.
Right,
And
right.
so there is all these other things that are technically true of the system when you're studying it and you're saying that, it's implementing this computation. And so, yeah, we can't say with the necessary and sufficient part of things is really difficult to get at. And it does permeate all of the theories. Yeah.
It's hard stuff. No easy answers here. I get it. All right, let's pivot to the global workspace theory.
So this one, kind of goes beyond just the visual system, and it's considered a more global theory in terms of involving more areas of the brain and involving kind of what are called kind of higher areas of the brain, the prefrontal cortex, things that kind of come after the sensory processing streams. And in this theory, there is this notion of there being a global workspace. So this is kind of a place where if information is in this workspace, it's experienced as a conscious experience. And the way things get into this workspace is that you have different modules. So it could be like visual information is coming in through one module, auditory information through another, maybe even like memory or other kind of processes that happen in the brain are coming in through other modules. And then for something to get into the workspace is kind of it's non-trivial because the workspace has limited capacity. So that's why not everything can be conscious. There's a limited capacity as to what can get into this workspace, and that is that kind of process happens through what's called ignition. It just means that something happens inside a module where its activity kind of gets recurrently activated, and that sends it into the global workspace.
Is this kind of like your brain's RAM, if you will, to use an old school metaphor? The idea that you have a certain amount of processing that's happening kind of like real time, and then beneath that, there's other systems churning along.
Yeah, it could be thought of like that. There's definitely, certainly the idea that it's limited and that, it kind of has to interact with other parts of the system to do the calculations that it wants to do at that moment. So you have those different modules, and then once information is in the global workspace, it can be kind of sent back to all the other modules. And so you can have elements of your auditory processing be influenced by your visual processing through an interaction via this workspace. And so this theory, it also has the kind of effect of maybe giving more, like more of a role for the consciousness experience for, because this global workspace is meant to have certain beneficial properties for how you combine information and how you select information and how you turn that information into action. And so it kind of is also describing something about how the brain actually works to, take inputs and turn them into outputs, kind of take in the world and create actions as a result. And so it puts a little bit more of a weight on what the consciousness is actually doing, instead of kind of describing the consciousness as kind of an extra layer on top of the information processing that's already happening.
Before we get to the third and final bucket we'll go into, I'm wondering on a meta level almost, I'm wondering if you guys are effectively describing possible frameworks, and literally the brightest minds in the business and a very hard business of neuroscience are developing these frameworks. Is there a weird meta issue where the folks who are developing AI and want to achieve breakthroughs in AI consciousness are like, aha, ding, 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 light bulb, this is the skeleton key to create consciousness, right? And so could they be, and maybe they already are, I don't know, maybe they have been. Obviously, very smart people are designing AI. Very brilliant engineers and scientists are working on creating these systems. Can people try and develop a system that kind of mimics a recurrent processing theory or global workspace to try and cobble together this framework to make it feel like consciousness? Is that something you guys have thought about?
Yeah, so in the report, in order to evaluate if current AI systems have these properties, we had to kind of translate from the neuroscience theories to AI language. What would this actually look like in an AI system? And so we come up with these indicators that are meant to say, according to this theory, the AI system would have to have these properties to kind of meet the requirements of consciousness with that theory. And so, that's a way to evaluate current models, but it's also a recipe for building models that would meet the requirements for these theories. And our conclusion is that none of the current models really meet that many of the requirements, but it's not that difficult conceptually to build a system that does. And that might sound scary, like this is a recipe for conscious AI, and it's not even hard to pull off. But I I think the way a lot of people in the field would take that conclusion really says more about the scientific theories of consciousness as they exist now. I think it kind of is highlighting that these theories are really incomplete. That the report takes what exists in the neuroscience of consciousness and applies it to evaluating AI, but that doesn't that doesn't mean that those theories are correct. I mean, the fact that there's multiple theories to evaluate means that this is not settled science in any way. And so, really, I think what might be the more impactful, or kind of what should be the more meaningful outcome of this exercise, is that these theories need more work for us to be certain of their truth, and to really make sure that they're capturing everything that's important for the neural correlates of consciousness. So yes, technically the report does provide steps by which someone could build the system, but I don't think that the conclusion should really be that such a system is conscious straight away, just because there's so much uncertainty in this process of, translating these theories and evaluating them and all of that. And then on top of that, as I said, global workspace kind of does posit a role for the consciousness in the computation, but outside of that, there's a question of, why do you want to build a conscious AI? It's not obvious that it will perform better than what we already have. That's a conflation people make, that maybe if it's conscious, it will have better intelligence and all these other things that go along with it, but that's not required. That's not a necessary component of consciousness in its most basic definition.
Interesting. It reminds me of the idea of companies or projects trying to almost cheat by using this kind of template. It could be a flawed analogy, but it reminds me almost of the paradox of standardized testing, right? And like, standardized tests are meant to be a fair, objective gauge of, call it knowledge, intelligence, academic achievement, what have you. But then at times you have the paradox of teachers kind of teaching for the test and students are just focusing kind of slavishly on trying to optimize these questions they're going to ask and like kind of gaming the test. And so you're not really getting at what you want to get at. You're getting at, how good are you at test taking? And I can see a world where this framework is being used almost like a standardized test, and AI development projects are optimizing to check off boxes of these frameworks, but might not really truly be getting at the spark of consciousness or sentience, if you will.
Yeah, it's very, at this stage of the scientific research, that's more likely than not that they'd be, checking off these indicator boxes, but that it wouldn't necessarily mean that there's something there.
Let's get to the third buckets that you are describing. Is that the higher order theories?
Yeah. So higher order theories say that the relevant computation that's happening for consciousness is that there is a representation of another representation. And so what that would mean in practice is, you have visual information. Again, I'm using the visual system as a default. It happens all the time. You have visual information that comes into the brain. There's, neurons that represent that visual information, and that would be the first order representation. Those neurons are encoding some information about what's happening out in the world. And then there's a meta representation. There's another, set of neurons or part of the brain that has a meta representation of that first order representation. And that anatomy kind of relates to the sense that consciousness means that you are aware of your own perception. You're aware of the visual information that's in your brain. And so there's like a set of neurons that's aware
cognito
of or
ergo
processing.
sum, right? Am I going to cognito ergo sum? I think therefore I am. Isn't that essentially?
Yeah, a little bit. Yeah. But yeah, so that's the flavor of the higher order theories, and they kind of manifest in a few different ways. But it's just this idea that you have this other layer on top of the actual information processing that's happening, because you could imagine a system like current AI models that do a bunch of information processing, but that they're not conscious of it. There's nothing on top of that. And this kind of puts that thing on top of it all, which is the representation of the representation that is meant to relate to awareness of what's happening, of what information is being processed.
So it's almost like they're aware of being aware, or where, oh, there's a memory. I have some system is trying to keep track of organizing certain data, right? Because let's say there's like 10 tetrabytes of data at my fingertips, yet by analogy, my short-term memory, the most useful 7 points of data I'm keeping in my kind of like front of mind. So the AI being able to think about, to realize, okay, I'm having like my quote unquote near term or short term memory or front of brain has this useful, relevant data and insights. Awareness of that is kind of what you're looking at here. I think I'm stumbling and fumbling here. Am I getting close to it?
Yeah, no, I think you're hitting on another, aspect of what it can explain, which you were kind of alluding to, that, it has more limited capacity. There's all this information you could be aware of in your brain, but you're not aware of a lot of it. And so this kind of existence of a higher order place that chooses what it wants to represent about the other information. So, like, for example, in our brains, there's a bunch of space dedicated towards controlling bodily functions like digestion and hormone release and all this stuff, and we're not consciously aware of that. And so, one of the main questions in neuroscience of consciousness is, why are you not aware of that when you are aware of these other things? And so if it is the case that there's kind of a part of the brain or a group of cells that's meant to be the meta representation of what's going on, it would mean that that information about hormone release would need to be represented by this population of cells as well. That would be like the awareness signal. And that doesn't seem to happen. We seem to only kind of put our awareness on certain other things like visual processing, or, how we feel in other ways, or what we're thinking about. So yeah, it's and again, it's a broad class of theories and it gets kind of manifested in different ways, but it's just that it's kind of meant to capture the intuition that, you can have information processing happening that you're not aware of, and then you're not conscious of. But when you're conscious, there is some sort of meta thing happening where you are aware of that information processing.
Got it. Thank you for clarifying that for me. So obviously there are many more different possibilities, and we won't exhaustively go through all of them. I'm curious though, what's your personal favorite? Whether it's one of these three or one we haven't covered yet, what if you had to kind of like put all your chips in on the table? Like, well, we don't know for sure, but this one to me feels most likely or most compelling given the limited knowledge and we have so far.
As I'm saying, and I want to keep saying, again, very early stages on all of this. I think, because it's so early, it's better to evaluate the models kind of on what they're aiming to do and what their potential is. And I think something like the global workspace model, because it's aiming to explain a lot of different components, like it's not just a model based in the visual system or something like that. It's kind of a more fully fleshed out system that interacts with itself, could be used to address more of the neuroscience data, has more kind of functional consequences in terms of how something being in the workspace impacts the behavior that the person produces and all of that. In that way, it seems like a more promising avenue for being able to put in more and more data as we discover it.
You kind of touched upon this a little bit already, but the next phase of the study, as I understand it, was to say, okay, here are the key possible criteria and frameworks. Now let's go through it systematically and look at all the AIs out there and see, do any of these check the boxes? What I think you already spoiled it with the answer is no. At the moment, they did not, and obviously that was kind of the main headline when the study came out a while back. But let's go one level deeper. Obviously, none of them roundly and slam dunk, yes, it does it. We did it. But what maybe surprised? Were there any that kind of came close? Were there any that you thought, actually, it's not quite there, but this AI system kind of within spitting distance of this framework? Anything like that you guys saw?
Well, let me just say we didn't evaluate all AI systems. There's a lot now.
But as we're during this recording, 5 more just birthed to the world. So yes.
So we looked at some main ones and some kind of canonical architectures that are used. And as I mentioned before, the actual way that you translate these theories to the models, to the AI models, it's not trivial. There are different kind of mappings you could do. There are systems where you could make an argument that maybe if you take a certain liberal interpretation of some of the requirements, then maybe these systems do match. And so, something like transformer architectures. These are kind of at the base of these large language models like ChatGPT. There are elements where they're showing some of these indicators of something like global workspace theory. You can have versions of these models that have different modalities that come in, or you could consider the multiple inputs, like you put in different words to a large language model. You can consider those as these different modules that feed into a global workspace. There is kind of an attention mechanism in these models where information from one module is allowed to influence the other modules, which is part of global workspace theory. So you can stretch it where there's some relationship, but it doesn't seem to really be getting at the large scale kind of meat of what the theory is kind of claiming is necessary. So yeah, there's flavors of these indicators in a lot of different models, and it makes sense because they do have computational purposes. Things like recurrence is helpful for processing data over time, and the kind of attention interactions, or the idea of having a kind of limited capacity bottleneck, which the global workspace is. There are good reasons for including that in a model. And so these things show up across a lot of different popular architectures, but they're just not fully there with all the pieces together.
What were the other conclusions from the study?
So as I mentioned, there was the conclusion that it wouldn't be difficult at this point in time to build a system that had all of these indicators.
Let's do it. You and me. Let's build this thing.
So that conclusion kind of actually relates back, interestingly, to the whole framing of the work, which again is to not use behavioral measures, to not care about kind of the input or the output of what the model is producing as a way of assessing it. But it also means that these indicators don't actually speak to how complicated or intelligent the system has to be. So that's part of the reason why it wouldn't be difficult at this point in time to build such a system, because it just needs to have these components in its architecture, in how it's functioning under the hood. But it could be like a really poorly performing AI. It could be far, far worse than
I've met many conscious people who are pretty poorly performing.
Yeah. And maybe that's fine, because as I said, there's no reason to believe that consciousness and intelligence have to be related in any way. But it definitely, without having those constraints on what the network needs to be able to do, then, in the world of machine learning, if you just want to build something and it doesn't have to perform very well, that's very easy. You can build whatever you want. Usually the tricky bit is actually making it perform a complicated task at a high level. And that's just not a part of how these systems are being evaluated for consciousness.
And is it possible that for it to be conscious, it might need all of them? I'd say, hey, it needs a higher order. It needs global workspace. It needs recurrent processing. It needs the other 37 frameworks that you guys have recommended. But I guess the real paradox here, getting back to where we started, is even then we might not really know, right? Because there's really fundamentally, there's really no way to know if these are necessary but not sufficient criteria for consciousness, right?
Yep. Yeah. So that's why I think of this report as, kind of a big if then table. Like, if this is true, if you agree with this assumption, if we're allowed to gloss over these details, then here's the outcome. But, if any of those chains break, then the conclusions don't follow as well.
Well, and it still is ultimately, if this, then maybe, right? Because like if it meets this criteria, it meets that criteria, then it exhibits behavior that correlates with consciousness. We don't know if it's conscious.
Yes.
Right.
Yeah, there's that level on top of it, the fundamental philosophical difficulty.
More generally, what kind of excites you and troubles you in the AI space as it continues to mature and develop?
Yeah. I can speak to the first to like the AI consciousness space in particular, but then more broadly. I mean, in this space, and part of the reason that I liked being involved with this report, I think there is a lot of hype and confusion and runaway beliefs that can happen when you're talking about, I mean, consciousness in general. It's a complicated area, and there's a lot of strongly held but perhaps not well-founded beliefs that sometimes people have.
No, that never happens in the world today.
Yeah. And then when you throw AI into the mix, and it's just a big jumble. And so I liked that this report was kind of a very, from my perspective, kind of a calm, just like,
Yes.
okay, if we want to walk through all of the logic, this is technically the state of what we know at this time, and this is what it could mean. So I'm just happy that that's out there to combat some of the kind of madness that can happen in this domain. In AI more generally, I'm excited by the progress, partly just, to exist in a world where that kind of technology is being developed. Also, as someone who studies natural intelligence in the brain, and having these examples of these systems that do things that we thought wouldn't be possible in artificial systems for a long time, it just gives you a new domain to discuss and to learn from, and tools to use to understand the brain. But I am concerned, especially with this big influx of generative AI, that the information ecosystem will be heavily degraded in years to come in subtle ways that we might not even realize are impacting our ability to understand the truth about the world, especially if we're trying to use, technology to do that.
Yeah, I'm deeply concerned of that as well. I wish I am generally an optimist. I have a lot of excitement about where things are headed, but the idea of getting harder and harder to parse out truth from faux truth, like almost looking fake truth from AI, is deeply unsettling. I mean, it's already hard now. It was hard 5 years ago. I can only imagine how hard this will be in 5-10 years. And I'll be having a lot of episodes focusing on that darker side soon. You mentioned a moment ago the misconceptions that are out there and how it's easy for people to kind of go on a runaway train thinking about AI consciousness. Let's unpack that a little more. What do you think people, or maybe multiple things, what are folks most getting wrong about AI consciousness?
I think that one of the major things, and it's not even specific to AI consciousness, but it obviously kind of matters most there, is this idea that consciousness has to come along with other things. Now, sometimes people think it's related to intelligence, and that's a little bit more benign, but sometimes there's an assumption that if an entity is conscious, then it will have a self-preservation instinct, that it will develop its own kind of wants and desires that are separate from what it had when it was in an unconscious state, that kind of thing. And I just don't think there's any technical reason to believe that these things need to be associated with each other. But that association leads to the kind of, fears of an AI becoming self-aware and destroying people and all of that kind of thing.
Interesting. So we haven't even talked about, I mean, I feel almost embarrassed to use this word, but emotions, right? I'm pausing here because my brain's kind of melting down, even wondering where, if at all, do emotions fit on the grid or landscape of neuroscience? And are emotions divorced from this subject? Or could one argue, are they inextricably tied in to the fabric of feeling alive? And is it possible that one of the frameworks is feeling things, feeling whether it's fear or love or jealousy or fun?
So, I mean, emotions are something that is perfectly reasonable as an object of scientific study. People study them in psychology and neuroscience. There's questions of, how do people describe their emotions? Under what conditions do they feel certain emotions? What are the neural mechanisms that are generating those emotions? And so from that perspective, in my view of it, it's kind of similar to something like intelligence, where it is a capacity of the brain. It serves a purpose. Usually there are reasons, for evolutionary reasons why certain emotions you could imagine would be useful. And so in that way, it's another thing that definitely is connected a lot to consciousness in people's minds because they feel their emotions, but doesn't have to be related to consciousness. You could imagine creating an AI that expresses emotions in an appropriate way. You know, if you tell it something that it didn't want to hear, it gets mad, that kind of thing. Like you can build an AI that has that, and, you can interact with some of these chatbots in a way where they can already give off that feeling. But that doesn't mean that they're conscious. And you can imagine a conscious entity that has kind of a completely neutral emotional experience. So from my perspective, again, there's no reason to assume from the outset that these things have to be related. They just are related in us because part of what we experience consciously is our emotional state.
Interesting. So we might think of, at a very reductive, simple level, we might think of part of being human, to be a little corny here, is part of feeling alive, is feeling emotions, is thinking, is being conscious. If I hear you correctly, these are almost independent tracks. Like, yes, part of being a human is feeling love and pain and anger. And yes, part of being a human is being conscious. And yes, part of being a human is to be able to move around and walk across the room.
Mm-hmm.
But these are perhaps independent systems. And feeling anger or pain or love is no more immediate to consciousness as or necessary as being able to walk across the room. Am I kind of getting that framework right?
Yeah.
Yeah.
And even if they are very tangled up in us, that doesn't mean that they couldn't be separated in a different entity.
I'm guessing you're reluctant to make like hardcore predictions. And obviously this stuff you said is early days and these are theories, and you guys have done like incredible work to clarify and clearly present the best theories we have now in a useful format and framework. But to have a little fun with this, what's your guess for when you think AIs might be able to rise to the level of checking off these boxes or being conscious to the best that we're able to understand? Yes, they are conscious. Any thoughts on we're months away, 50 years away, years away? I mean, I know that you're not, no one has a crystal ball, but you're closer to the subject matter than 99.99999% of humans. So what are your thoughts on that?
Yeah, I mean, as we said in the report, by these indicators, we're not that far. But these indicators are, I'm going to say, almost certainly not complete or correct. And so, I mean, really, to be able to consider how far we are from being able to make the conclusion that AI is conscious, that requires probably a paradigm shift in how we study it scientifically, or a couple paradigm shifts. So in some ways, that's the limiting time constraint. There is getting the science of it sound enough that we would be able to say that kind of thing with certainty. And yeah, also it's just in general, extraordinary claims require extraordinary evidence, and so I think a lot of people, even who develop these scientific theories of consciousness, if there was an AI system that matched the indicators that we provide here, I don't even know if those people would really believe that the system is conscious, because there is a huge hurdle to overcome. And especially if there's no behavioral difference, if it's not like providing some leap in the abilities of the AI, there wouldn't be any instinctive sense that anything is different about it, and that therefore it should be considered conscious. So I just think that there's a question of when will we be able to have built conscious AI, and technically the answer is maybe we already did and we don't know, maybe never. We don't even know the answer to that. And then there's the question of when would we be able to with certainty say that we have, and that's or that it's not possible. And that's very far off because that requires a lot of progress in the philosophy and the science of it.
It's so interesting. I personally think, for what's worth, that it'll be pretty sooner than most of us realize when we're in a world where we're getting faked by it, where it might look to, by all accounts, it will look and feel like an entity that is conscious. And I think at that point, things are going to get really tricky as far as you'll have people on both sides. And I think I like the way you framed it, that you're going to have folks who want more proof, who will never be satisfied this is conscious. And you'll have folks on the other side who maybe perhaps prematurely are convinced, look at that, they look conscious. And that, I think, will cause so much tumults and controversy in ways we are nowhere near to wrapping our arms around. It will be interesting.
We're already seeing the seeds of it. So
absolutely. Any other final question for you? Any other predictions or just thoughts about the future? It doesn't have to be AI consciousness. It could be any element of AI of your choosing.
I mean, I don't, I don't know what will happen, but I think the one of the bigger frontiers that's left is motor control. The AIs that we're talking about now are chatbots, image generators, that kind of thing. But actually figuring out how to robustly control a body in the real world is a pretty difficult problem. And especially as someone who's at the neuro AI interface, it's exciting when there's an area where it feels like neuroscience might actually be able to help. Because right now the AI is kind of off on its own train. The people who build these systems, they're not looking that much at how the brain works for their inspiration. And that's because a lot of these other areas are just, they're successful as they are and they don't need that inspiration right now. But motor control is an area where it seems like maybe there is room for looking at how brains and bodies work and how brains control bodies as a way to inspire how to build better robots.
I love that. Can I give you my spiciest take, piggybacking off that? My spicy prediction, and I'd love to hear a neuroscientist. You could laugh at me for this, but my wild thought is within our lifetimes, we will actually be in a world where there are, and I'm embarrassed to use this word, but like replicants, right? It's a wild thought, but robots that actually look like us. I think in the next 30, 40 years that can happen. It might my logic for this is we're already in a world where we have compelling chat GPT experiences, right? That can easily be bolted to voice, that then bolted to video. We already see it. We already see kind of deep fake people real time talking. As you point out, robotics AI will improve, probably rapidly improve, especially if they embrace kind of neuroscience AI. And so then I feel the last real step is facial, being able to realistically map expressions to faces and getting the humor, if someone tells a joke to PT, to like in a non-creepy way smile. And that's probably a really tough physical scientific problem to crack, but I think it will be solved in the next 20, 30 years. So at some point, I think we'll have robots that look like humans on the world. That's my wild thought. So what's your, I mean, you already laughed at it, but what's your reaction to that?
No, I mean, I totally agree that a lot of the kind of base components we have, or they're, rapidly developing, that the actual robot itself is the kind of slow part in this. But yeah, if that happens, then you can piece these things together easily enough. If there's kind of a reason to do so, then yeah, it'll probably happen.
Really enjoyed the conversation. Thank you so much for you helped demystify a very complicated, tricky subject. You made legible for me and listeners. Thank you so much. Really enjoyed.
Great. Thanks for having me.
So there you have it. Thanks again to Professor Lindsay. And thank you, listeners, for following along. I know parts of this were a little tricky, but I, for one, came away with it with a good handle on what we know and what we don't know and what we might never know about AI consciousness. Obviously, this is still an evolving field, and we will have more to say on this in the future. And on a more mundane note, if you have not already, please subscribe, rate it 5 stars, share with friends, loved ones, enemies, strangers, AI bots. Thanks again, and see you next time.